In this video, we will look at how to do bracketing methods in Python. Okay, so you would define your function. So let's call ours the bisection method. And I'm going to do like a simplified version. So in this case, you need a function that you're trying to solve. You're trying to find the root for. You have limits, the lower limit and the upper limit, and max iterations. Now, the first step would be to find your root. So using bisection's equation, it's just going to be xr, the root, equal to the average of xl plus xu. So xl plus xu divided by 2. This should give you the root. Now, you want to break your intervals into two parts. So you started with xl and xu, and you want to break this down into two intervals. So you have xl and xr, and you have xr and xu. Now you want to know which of these has a sign change happening. If there is a sign change in one of them, that's the next subinterval that you want to look into. Okay, so how do we detect a sign change? You just execute, or you find the value of the function at that particular point. So let's look into the first interval, f of xl multiplied by f of xu. Okay, sorry, f of xr, the first interval, the first subinterval. If there is a sign change, that means when you compute this number, the function on the left multiplied by the function at the root, or xr, the number will be negative if there is a sign change. If there is no sign change, then the number is going to be positive. So there is a change. So if this happens, then your next root, put a colon here. Okay, your next interval is going to be, so my next search interval is going to be xl comma xr. Okay, now if the other part is, so let's look into the other interval. So xr multiplied by f of xu, there's a sign change. So if this condition is not true, then it'll go to this condition. So this has to be else if this is if this is 0, if there is a sign change in the second interval. So this is a comment, sign change in the first interval. Okay, so if there's a sign change in the second interval, then your new search interval is supposed to be the second interval. So xl comma xr comma xu. Okay, this has to be a list. Okay, and that's pretty much it for the bisection method. So let's print all these values. I'm going to use a formatted string. You can say xl equal to, and xu equal to, and xr equal to. Okay, and that's our function. If we defined our function, now we need to give it a mathematical equation to solve. So in order to write mathematical functions in easily, there are two ways. So the original way would be to define a function. So define f of x, and then you say return f, return whatever your equation is. So if you have x times 2 plus 2, and now if you would like to call the function, so this is defining the function. If you'd like to call the function, just say f of whatever number you want. Okay, and this will give you the required output. This is one way. Another way to write functions is using lambda functions in Python. So you can do one-liner functions. So you can just say f equal to lambda, and the same thing here, you have input x, so you just mention that as your input x over here, and then put a colon, and then write your equation. So x times 2 plus 2. Okay, so now I can use it in the same exact manner and get the same result. So these both are okay. Whatever you prefer, you can use that definition. I prefer this one, so we're going to continue with this. So let's make a function. Let's do something that you might have seen already. So 10 to the power x to the power 10 minus 1. So the solution for this is going to be 1. Let me run this. If I do f of 1, I should get 0. Yeah. Okay, so this is the root. Root is 1. So let's put a bracket between this, so 0 and let's say 1.3, and see how our bisection method functions. So bisection, give it the function, and we're going to give it a initial bracket of 0 to 1.5, let's say. So you have to, your program is not smart enough to detect whether there is a sign change in the given interval or not, like in the first interval. So you have to make sure that there is a sign change in the first interval. Okay. And then give it the max iteration. So let's say do this 10 times. And yeah. Okay, it printed it once. Oh yeah, we forgot to write it into a loop. Okay. So the first step seems to be fine, 0 and 1. So if this was 2, no, this was 1.5. So your root will be 0.75. So this seems to be working okay. All we have to do is just put this inside a loop, this entire thing. So we say for I in range and then max iterations. So this will run it max iteration times. So in our case we said 10, it's going to run this 10 times. Okay, so run this function. And there you have it. So you can see how the root is now approaching 1. So this 0.75, 1.1, it's getting closer and closer to 1. So which is the root that, like we mentioned before, okay, which is the true root. So there is one condition that we missed. So for example, if I had chosen 2 here, so the first bisection will give you the root. Okay, so if I run this, so you can see you already found the root. Okay, so this should have been a condition added to your system. So if there is a sign change in the left bracket, do this. If there's a sign change in the right bracket, do that. Else means you actually found the solution. So you found. Okay, if you found the solution, then you can just break, or you can just say return to stop your function. Okay, maybe you can do a message as well, print fprint solution root is, and else okay, this one, yeah. This one should be here outside the loop. Okay, that's our function. So if you run this now, it should tell you, like in the first step itself, it found the root. So that should be fine. If this had been, let's say 4 with division, it should reach the root quickly as well. So I mean, this doesn't happen very often, so you can kind of skip it. Okay, so that's how to write a bracketing method in Python. If you want to change this to the other methods, you can come back and just change the equation for the root. So if you have false position, just write the false position equation over here. All right, thank you.